you ever asked a generative AI app like ChatGPT a question and found the answer incomplete, outdated, or just plain wrong? What if there was a way to fix this and make AI more accurate? There is, and it's called Retrieval Augmented Generation, or simply RAG. We expect large language models, LLMs, to know everything, to be up to date, and to generate factually accurate responses every time. But the reality is that LLMs fall short due to three main limitations. The first one being a knowledge cutoff date. Training an LLM is an expensive and time consuming process. It takes massive volumes of data and several weeks or even months to train an LLM. The data that LLMs are trained on is therefore not current. For example, GPT-4o has knowledge only up to October 2023. Any event that happened after this knowledge cutoff date is not available to the model. LLMs are trained on large volumes of data sourced from a variety of places, but they do not have any knowledge of information that is not public. Publicly available LLMs have not been trained on information like internal company documents, customer information, product documents, etc. So LLMs cannot be expected to respond to any query about such information. And finally, by design, LLMs are next word predictors. They are not designed to verify the facts in their responses. Thus, it is observed that LLMs sometimes provide responses that are factually incorrect. And despite being incorrect, these responses sound extremely confident and legitimate. This characteristic of lying with confidence, called hallucinations, has proved to be one of the biggest criticisms of LLMs. Does that mean this technology is not useful? Absolutely not. LLMs can consume and process information very efficiently. If you can point an LLM to a source of information, it can process that information and generate accurate results. This source of information can be your company documents, third party databases, or even the internet. Now, when I ask an LLM a question like, who won the 2024 T20 World Cup, and provide a source of information, the LLM can process it and respond with the correct answer. This is the main idea behind retrieval augmented generation. And in 2024, it is one of the most widely used techniques in generative AI application. How does it work? At the core of the system is still an LLM. We all know that when we prompt an LLM, it generates a response. But we've been saying that these responses can be suboptimal and inaccurate. If we can find a way to search through an information store or a knowledge base to fetch an accurate source of information, then add this information to the prompt and pass it to the LLM, we can expect the LLM to generate responses that are accurate and rooted in a verifiable source. To enable the search and retrieval of information, a retriever component is introduced into the system. So now the three steps of the process become retrieval of accurate information, augmentation of the user prompt with the retrieved information, and lastly, generation of an accurate and a contextual response using an LLM. RAG systems today power applications like search engines such as Perplexity, Google, and Bing, advanced question answering systems, and conversational agents like customer support bots. RAG also enables personalization in AI generated content and is being used in educational tools and legal research, amongst other domains. So, how do you build one? The retrieval, augmentation, and generation components need to be set up. These three components form the generation pipeline that the user interacts with in real time. The generation pipeline retrieves information from the knowledge base. Therefore, it is critical to establish a process that can create and maintain the knowledge base. This is done through another pipeline known as the indexing pipeline. We start by connecting with the source of the data and extract information from the files in these source systems. After extraction, the parsed text is broken down into smaller chunks for efficient search and retrieval. These chunks are then converted into a numeric data pattern called embeddings, which facilitates semantic search. Finally, these embeddings are stored in specialized databases called vector databases, which efficiently store them. These four steps result in the creation of the RAG knowledge base. The indexing pipeline is not a real-time process, but can be executed on demand or at periodic intervals when data in the source systems is refreshed. Now, in the generation pipeline, the retriever searches the created knowledge base using one or more retrieval algorithms. The augmentation step falls under the domain of prompt engineering, where techniques like controlled generation, few-shot prompting, and chain of thought are leveraged. The generation component is created with one or more LLMs, which can be fine-tuned for specific tasks. Several advanced techniques to optimize the knowledge base and the user query for accurate and efficient retrieval, hybrid and adaptive retrieval strategies for better precision and recall, and post retrieval interventions to create optimized prompts for the LLMs are employed to enhance the efficiency, robustness, and accuracy of RAG systems. Two RAG patterns in particular, knowledge graph based RAG and agentic RAG, are gaining significant traction in handling highly complex query types. RAG is a simple and effective technique to fulfill the promise of contextual AI and make AI systems comprehensive, up to date, and reliable. If you are leveraging or planning to leverage generative AI in your work, an understanding of this technique will go a long way. If you want to build contextual AI systems that fulfill their potential, my book, A Simple Guide to Retrieval Augmented Generation, will be a good starting point. Early access is available at a discount at manning.com. You can scan this QR code to get early access discounts. Thank you for listening in. My name is Abhinav and I talk about data science, machine learning, and AI. If our interests align, I'd love to stay connected on LinkedIn, Twitter, Instagram, and Medium. I hope you found this video useful. Please like and share it with your network. And let me know in the comments how you are using generative AI technology in your work.